the first or second speaker have already introduced something like LLMs or what Gemini is. So the only thing new here I'm going to talk about is PGVector, right? But before we go deep into this topic, it's not something that is complex. At least that's my job, to demystify building with Gemini and PGVector. Okay, but before now, the speaker that was here before Patrick, he talked about data protection, and I want to say thank you for that talk, because data protection is often sidelined when building impactful products. So now the difference between impactful, successful products is just excellence. While building side projects, while building gigs, a little touch of excellence to your products will impact the usage. So thank you. Now, recommendation system. Most of us who have seen e-commerce apps like Jumia, Amazon, we have even watched Netflix, where after watching you see movies like this for you, or after buying something from e-commerce, you see recommendations like recommended products. And before now, like before LLMs, before embeddings, why implementing search systems, why making recommendation systems like that, we often use keyword-based recommendation. I don't know if we have backend engineers in the house. Any backend engineer in the house? Wave, please. Okay. Front end, mobile. Yes. This is not an AI talk. Let me just say it's just web development or software engineering talk. Now, the difference between intelligent recommendation system is it goes beyond keyword. Let's say with SQL queries, we use, let's say, a like keyword to search, but we want to move beyond the like keyword. We want to have a more context-aware kind of recommendation. So that is adding some form of intelligence to your system. Next slide, please. Now, how embedding and vector databases enhance recommendation engine. Okay, what is embedding? Embedding is more like converting content like text into numbers. We call that numbers vector. So vector holds a lot of context to content. Without, like, beyond text, it holds a lot of context. Why is this text here? What is the meaning of this text? So vector kind of captures those data. And when we have more context kind of data, we'll be able to perform more efficient kind of queries, search, optimization. Next slide. Next. Yeah. Embedding is a way of representing data as numerical vector in a multi-dimensional space. For example, in a vector space, the word king can be represented with this array of numbers. So now, when you look at king and look at the numbers, in a normal traditional database like keyword search and all, when you search for king and it matches what is in your database, you will see result as king. But in a context-aware system, let's say you search about rulers, something like king should appear, because it's no more about the keyword. It's now something like it has context and semantics. Next slide. So why use embeddings? It is more efficient, definitely. You just bought an iPhone cord on Amazon. Very soon you start seeing recommendations to buy the charger head. How did they know you bought iPhone cord? So it is because of the context of your purchase they use. And by that reason, they more like embedded your user data to be able to power your recommendations. They have been building recommendation system. Netflix has an awesome recommendation system. Big e-commerce has an awesome recommendation system. But bringing this down to Postgres level will kind of incite us to build recommendation system. Before PGVector, there are other vector databases being used, like Pinecone. But it's more like when you begin to start going far, implementing extra stuff, your system might become complex. So we are trying to bring it down into our day-to-day development. So that is where PGVector comes in. PGVector is an extension of PostgreSQL where you can store vector databases. So with PGVector, you can store vector databases. You can also query vector databases. And next slide. How simple it is. This is just how simple it is. Just these three liners, you will be able to get an embedding of a text. Let's say you've already designed your system as the user. Let's say the user search for book. You can convert the book into a vector. With these three lines, you can convert the book into a vector. Then it returns a set of numbers that I explained as they are called vectors. Next line, please. You now be able to insert that vector in, let's say you are using Postgres, insert the vector the same way you insert values to your database. As simple as that. Now, the next step is you've gotten this vector in your database. How do you want to use it? It has numerous use cases. It can just be to check recommendations. It can be to power search. For example, you go to Udemy, you search data science. Of course, they will give you data science courses. But what if you go to Udemy, you search a course for data science? When building that, a course for data science, the keyword has shifted. It needs a context-aware system to refer data science courses. Now, you can embed user searches and use that user search to get recommended results, depending on how the user twists the keyword, because you have shifted from keyword-based search to context-aware search. Next. Now, this is just how it works behind the hood. We call it cosine similarity because cosine similarity, just to compare between vectors, which of them is more similar to the other. And while comparing between vectors, for backend engineers and software engineers here, you'll be able to have what they call similarity number using dot products. You'll be able to know how far is this result to what the user wants. And when you're able to rank them, trust me, that is how you're going to be able to give them the perfect recommendations they want. And this is how systems, like I often use Netflix as an example. You finish watching a horror movie and they're asking you more like this, giving you a super horror movie. It is not the same title, but because they understand the context, it's not even about even if it's Spotify, it's not about the genre or whatever the music is. They understand what you like. And that is how it works under the hood. Next slide. Now, real-world use cases, content recommendation for streaming platform, e-commerce products recommendation, personalized learning in EdTech, social media, and networking. Sometimes you might just finish Googling stuff on Google. Next thing, you start seeing ads on Facebook about what you just Googled. It happens. Most of us might have experienced it. That is how they are shifting from a context-aware search, from a keyword search to context-aware search. I don't know if I can do some demo, but if you're able to scan this QR code, you will see a guide end-to-end of how to implement a simple recommendation system using Node.js and Express. I understand most of us might be more familiar with Node.js. So once you scan this code, I wrote an article about it, end-to-end guide. Thank you. For backend engineers or front-end engineer familiar with Postman, I'm going to just show you how it works real time. Now, we'll look at the responses. You just bear witness that none of the responses has the keyword called geography, but they have a little bit of relations with geography. So this is, firstly, the steps to make this kind of system work is embedding the content, then making the search. There are two steps. I'm going to make a recommendation, but I'm also going to embed the content. Now, when I search for a keyword called geography in my data set, I was able to get these results. Although these are like dummy data I've added to the database. When you look at the results, they all revolve around geography. I don't know if that makes sense. Now, let me embed okay. Let's say let me embed the title of, let's say, the first 5 workshop speakers, and we'll be able to get a, let me get it, please. This is the embedding of the title. At this point, it has captured the context and the semantic of how I want to use that data. I can do a lot of things with this data. I can sort, I can search, I can recommend, and all. I'm going to make the next, this previous speaker before me. Yes, I've been able to vectorize like 3 titles. So let me recommend something like data vectorization. Did you see my own is the top? I don't know if you can see the response, but did you see anything like data vectorization in the search, in the recommendation? I don't know if that makes sense. I've been able to vectorize the data, and I asked the system to recommend something for data vectorization, and it gave me context, but my own title, which is more related to data vectorization, was the top in the recommendation. So the idea around this is to building intelligent system, and I believe I've been able to like conclude that. If you have any question, if you need guide, you can scan the QR code. If you have any question, you can ask me directly. Thank you.